Good day students, myself Dr. Smita Sharma, Associate Professor Physics. I am going to teach Operational Amplifier, Basic Introduction. Now what is an operational amplifier? An operational amplifier is basically a direct coupled high gain electronic voltage amplifier. Direct coupled means in order to connect two stages of an amplifier, we do not need any coupling devices. They are directly coupled to each other. It has differential input and usually a single-ended output. Operational amplifier is in short also termed as op-amp. Now, why it is called operational amplifier? This is called operational amplifier because it can perform the basic mathematical operations of addition, subtraction, integration, differentiation, etc. Now this is block diagram of an op-amp. Op-amp basically has these following three stages: input stage, intermediate stage and output stage. Input stage consists of a differential amplifier along with a constant current source. The differential amplifier basically has two inputs. They are named inverting input and non-inverting input. The intermediate stage consists of differential amplifier, not one, there can be many, along with emitter follower and a level shifter. After this stage we get output stage, which is generally single-ended. Now since we see in the block diagram, the most important first stage of op-amp is a differential amplifier. So first of all, we will study differential amplifier. Now what is a differential amplifier? It is obvious, it is input stage of an operational amplifier. Its function is in general to amplify the difference between the two input signals. Let us suppose we have a linear active device, and in this linear active device there are two inputs V1 and V2, and there is single output V0. With these all voltages are measured with respect to ground. So by the definition, the output signal V0 should be AD V1 minus V2 as shown in equation 1. Here AD is the gain of the amplifier. So in differential amplifier, if we think ideally, if it is seen that if any signal which is common to both the inputs will have no effect on the output voltage, that is, output voltage will be 0. Here the value, here in equation 1 we haven't considered the mean levels of the input signals. Now what do you mean by mean level? We can understand it in a simple way. Let us suppose in a certain first state we have V1 10 volts and V2 minus 10 volts, and in some other state, second state, we have V1 410 volts and V2 is 390 volts. Then in both the state, the output signal according to equation 1 will be 20 volts, but the mean levels are completely different. In first case it is 0 and in another second case it is 400 volts. So ideally it doesn't matter, but in actual practice differential amplifier cannot be described only by equation. So output depends not only on the difference VD of the two signals, that is V1 minus V2, but also on the average level called the common mode signal Vc. Here Vd is V1 minus V2 and Vc is V1 plus V2 divided by 2. So actual practice we have to consider both Vc and Vd. Now in order to make differential features, what do we need? What are the essential features of differential amplifier? Basically, we need two transistors Q1 and Q2 with their emitters connected together, two input terminals, two output terminals, and a constant current source. Now, how can we make a differential amplifier in a simple way? To make differential amplifier, we take two emitter biased transistor stages and join two emitter ends and both the collector ends. We finally get a differential amplifier. The output will be the difference of the two if the output is taken across both the collector ends. Now, differential amplifier can be provided input in several ways. These are called mode of application of inputs. Now, what is mode of application? What can be the mode of application of input are shown in this slide. There can be four types. First, the input can be provided in input 1 and earth, between input 1 and earth. Second, the input can be provided at the end 2 with respect to earth. Third is the case where the two inputs are provided both at input 1 and input 2. And fourth is the case where both the inputs are joined together and given one type with respect to earth. These are four modes of application of the input to the differential amplifier. Now, what happens when an input is provided to the differential amplifier? This we will study in the next coming slide. Thank you.